Alright, here we go. Let's keep going with this thing. So there's a common denominator. So now what do we want to do? I'll tell you what, let's do this in red because I like to show it a little bit different. Now, what do we do to this to get to this? Well, we had to multiply by a 2, right? So we're going to have to multiply, watch, we're going to have to take this and multiply that by a 2. What else is missing? The y's already there, but there's another y minus 1, right? So I'm going to have to multiply it by another y minus 1. Right? Gets a little bit involved, but I think we can handle it. All right, so let's go here. What do we do to this? Well, there's a 2 already. There's a couple y minus 1's already. What's the one thing that's missing? The y. So what do I have to multiply the top by? A y. Okay, you see what I did? So I said, what did I do to this to get to this? Well, the y's already there, so I didn't have to multiply it by a y. There's already one y minus 1 here, so I had to multiply it by another y minus 1, and I also had to multiply it by a 2 to get to this. So what was missing? All right, if you want to think of it that way, just say, hey, what's missing from this to get to this? A 2 and a y minus 1. So you multiply the top by that. Okay? Now let's do this. I don't like that 2 right in the middle there, do you? Oh, yeah, we'll just do that. And let's put the 2 right out here like this. Is that all right? So let's do some multiplication here. We can FOIL this thing. Can you do that in your head? Tell you what, let's do a little work right here. Let's put a 2, right? And let's figure out what this is. So it's going to be a y squared, right? And then it's going to be, what? Minus y plus y, which is plus y, and then minus 2. Do you agree? See what I did? I'm multiplying these two together first. Right? Just did FOIL methods, all I did. Alright, and that's what I got. Now, let's go ahead and distribute the 2 through this. So what do I get? 2y squared plus 2y minus 4. Alright? So that's my numerator for this fraction. Brian, you're a little confused. What's wrong? I took this and this, multiplied together. Y squared minus y plus 2y. Minus 1 plus 2. Right, it's minus y plus 2y. It's minus y plus 2y. So it's negative 1 plus 2. Negative 1 plus 2 is 1. Okay? And then minus 2. Then I took it and multiplied it by the 2, and that's how I got that thing right there. Okay? Let's do this. This is an easy one. What's that going to be? Just minus what? 3y squared. Now, do I just leave it like that and circle it? No, I don't want to leave it like that because I got a like term I can add, don't I? I've got a 2y squared and a minus 3y squared. I need to combine those, all right, because you need to simplify it. So that's the only thing I really have to do. So what do I get? I get minus y squared plus 2y minus 4 over, and then I don't have to mess with this at all. I'll just write it all out. There you go. It's an ugly looking answer, but that's what it is when I subtract those two things together. All right. I mean, this is just, it's practice. You know, are you gonna do this stuff? You're gonna have a job where you got to sit down, you got to do this? No. All they're trying to do, look, all they're trying to do is make you think, all right, and make you understand what you're really doing when you're finding, you know, when you're adding or subtracting fractions. Okay. I mean, and this really gives you an idea if you understand what it is to find a common denominator and all that kind of stuff. And it also practices other things. Look, we practiced the FOIL method here, didn't we? We practiced adding like terms and all that kind of stuff, all right? So it's good practice on a lot of different levels. Okay, this is example 4 from the book again. I don't know. Does anybody got their book open? Anyway, it's it doesn't matter. It's on section 1.5. Look at example 4 and you'll see this right in here. These things are called complex fractions. Now, they're not called complex fractions because they're really hard. It's basically like a combination of different fractions. It's basically a fraction in a fraction is a complex fraction. Remember in English class, didn't you learn about like compound sentences and complex sentences and all that, simple sentences, right? I mean, I had English years and years and years ago. But I think if I remember right, weren't complex sentences like a combination of like a simple sentence and a compound sentence, or two compound sentences or something like that? Wasn't it something like that? You guys remember any of that? You're not doing any of that stuff this year? Okay. So anyway, but that's what complex means. It's like a combination, right, of different types of things, and that's what this is. It's a fraction. So if I had something, I'll go real simple here. What if I said like 3/4 divided by, I don't know, 2/3? Okay. That right there is a complex fraction because look, I've got a fraction and a fraction, and they're all in one big fraction. Do you see that? So this fraction is actually a numerator, and this fraction is actually the denominator, right? It's part of one big fraction. You okay with that? So how do we think about complex fractions? Well, this is what I do. This fraction means divide, doesn't it? So it means 3/4 divided by 2/3. Well, we already talked yesterday what it means to divide. Instead of divide, what do? We multiply by the what? Reciprocal. So instead of 3/4 divided by 2/3, it's 3/4 what? Times 3/2. You with me? Okay, and then does anything cancel here? No, so it's just what? 9/8. You okay with that? Now that's about as simple as we can get. What if we did this? What if we did a over b divided by c over d? It's the same idea, isn't it? It's a over b times what? The reciprocal, d over c. If you wanted to write it nice and neat, what would it be? AD over BC. Whoops, it's supposed to be a B. Okay? You got the idea what a complex fraction is now? All right, so that's really what a complex fraction is. That's a very simplified version of a complex fraction, but now we're going to use some of the things that we did earlier, and we're going to apply them to complex fractions, hopefully. Let's see if we can get them right. Okay, here's the example. This is actually example 4. I erased it, but it's 1 plus 5 over k. All right, let's look at this. This is a complex fraction because look, we got all this mess as a numerator, right? And we got all this mess as the denominator. Do you see you have a fraction inside a fraction? That's why it's called a complex fraction. So the first thing we want to do though is to simplify the numerator, simplify the denominator, and then we can apply what we just learned as far as multiplying by the reciprocal. We don't want to do that yet, okay? Don't try to multiply by the reciprocal just yet. Let's take this and simplify it before we do anything else. You okay with that? So let's kind of do this off to the side and then we'll come back and do this. So watch what I'm going to do. It's 6 over 1 minus 5 over k. What do we have to do? We've got to find the common denominator. I'm going to do this a little bit quick. So the common denominator is k. 1 times k, so 6 times k, so that would be a 6k. What do we do to k to get to this? Times by 1, or really, we basically didn't do anything, did we? So we don't mess with that, so it's just minus 5. That's what our numerator is going to be. See how I just kind of did this off to the side? Now I can chuck it back up to where it's supposed to go. So what do we get? We get 6k minus 5 over k. You with me? Let's do the same thing to the bottom. Let's do this down here off to the side. So it's 1 over 1 plus 5 over k. Do the same exact thing. Common denominator, k. 1 times k, 1 times k. So that's a k plus what? 5. You okay with that? Lots of k's floating around. K plus 5 over k. Are we done though? No, it's still a complex fraction. You still got a fraction over another fraction. Now we can apply what that fraction means. It means divide, doesn't it? That's what a fraction is. It's the top divided by the bottom. So let's take the top, 6k minus 5 over k. Instead of divided by this, what are we going to do? We're going to multiply it by the reciprocal. So what goes on top? K goes on top, and on the bottom, k plus 5. Now we're going to multiply these together. Remember, this is multiplication, so I can put that in parentheses if I want to, couldn't I? What can we do here? Does anything cancel out? The k's cancel out. That's right, because that k is being multiplied by this, isn't it? So that cancels with that. That's all you can do. All right. Do the 5's cancel out? No, why not? Well, they're being added, right? Being added or subtracted, okay? That's the reason why you can't cancel them out. Same thing with the k. Even though people say, yeah, but the k is being multiplied by 6, but that whole term that k is a part of is being subtracted, right? From something, or something's being subtracted from it. You with me? So nothing else will cancel out. You just leave it like that, and you're done. We good? That's a complex fraction. It's not that hard, is it? What do you do, though? Simplify the top, simplify the bottom. We did it right here, and then you can go ahead and multiply by the reciprocal. And then once you do that, then you're done. Let's do another one. It's a little bit trickier. Okay, look at this thing right here. It says simplify, basically, is what we're doing to these things. So what do we do first? Do we multiply by the reciprocal right now? No, you simplify the top, simplify the bottom. So how do we simplify the top? Well, we add those fractions together, don't we? So I'll tell you what, we'll do all this within the fraction. On the other problem, we went off to the side, you know, but on this one, I'm just going to do everything up here. So if I'm going to add these together, right, that's my denominator for this, I got to find a common denominator. Well, I've got an a here, and I've got an a plus 1 here, right? That's acting as one denominator. So I just multiply those together. So it's a times a plus 1. Make sense? Look at the other fraction. It's going to be the same exact thing, isn't it? So it's going to be a times a plus 1. Alright, I'm going to go in red this time just to make these stand out a little bit. So now what we have to do is say, how did you get from this denominator to this denominator right here? Well, what did you do to a plus 1 to get to this? Multiplied it by what? A. So what do you do to the top? Multiply that by a as well. You see that? Alright, let's go to this one. What did you multiply a by in order to get to this? A plus 1, right? So I multiply that by a plus 1. We good? Since we're on a roll here, let's do the same thing on the bottom. A times what? A plus 1. And then a plus 1 times what? A. There you go. Alright, and now let's see what we get here. A times a is a squared plus, what's this? 1 times that? That's just a plus 1, isn't it? Pretty easy so far, right? What about this thing? That's just a plus 1. And that's what? Plus a. We're still not done simplifying it. Let's still simplify. Let's see what we get. A squared plus a plus 1. Can you can that factor? It looks like it might factor, but it doesn't. Alright, because if I try to factor it, something times something is positive 1. If I used a 1 and a 1 and I added them up, what would I get? I'd get a 2a, wouldn't I? I wouldn't get an a. So that doesn't factor. So I'm going to actually, yeah, because that was my first guess of what might possibly happen. You're not packing up already, are you? We're not done. Look, there's the top. Instead of the top divided by the bottom, what are we going to do? The top times the what? The reciprocal. That's right. So I'm going to take this, I'm going to flip it. So I'm going to go a times a plus 1, and then take this. A plus a is what? 2a plus 1. You okay with that? Alright. Now, what happens here? Yeah, see, right, that's all multiplied. See, everything's being multiplied, isn't it? All the parentheses in that a. So that a will cancel out, and the a plus 1 will cancel out. That's nice. So what are we left with? A squared plus a plus 1 over, what? Just 2a plus 1. Do the ones cancel out? No, because they're being added. All right. Again, as soon as I saw this, it looks like one of those trinomials. Right? We talked about it a second ago. I always try to see if that factors. Well, this does not factor. Right? So I can't do anything with it. Nothing else cancels out. I'm done. We leave it like that. Yeah, if you had a 2 here, then it would factor. Yeah, then it would factor. It still wouldn't cancel with anything down here, but still I would try to factor it though. Okay, if it looks like it factors, I try to factor it. If it doesn't, I just leave it the way it is. We good? All right. Now you should be able to finish up. You should be able to go 10 to 20 now on that worksheet. Okay.